Good evening, students, and welcome to our next live session on TCS Digital Training. So, let's begin without any delay with this live session. So, the first thing I want to point out to everyone is to just confirm that all of you, as usual, are able to see the screen properly and hear me properly as well. You guys can just put a message in live chat to just let me know if you all can see the screen properly and hear. I hope everybody can without any issues. Perfect. Glad to hear that. So let's quickly go ahead and start our session today. We're going to go through this particularly special kind of hollow pyramid program. Now, here's the thing. Till now, we have gone through a few different kinds of programs. So today, we're going to go through a special program called a hollow pyramid program. It's basically like this. Let me just take a screenshot of this so that I can explain. Okay, here it is. So it's somewhat like this, where we're gonna have a pyramid pattern like this. Now the difference is, in our pyramid pattern, generally we fill the pyramid, or in our diamond pattern, generally we fill the diamond with values, whatever it should be. But this time, we're gonna take a diamond problem, and what we're gonna do here is fill everything except for the diamond. We're gonna take such a diamond problem, let's say, and we're gonna fill all of this except the diamond. That is all over here. Here we're gonna fill the data, then here, and then here. That's our entire logic. Now, how are we gonna figure this out? How are we gonna exactly start with this? Let's try to think of a logic. Before that, I have a question that I've been asked by one of you. There is Jyoti. I have a query. Will these live tech sessions provided by you sufficient enough to crack TCS Digital? See, here's the thing. TCS Digital purely asks coding questions. All right. And in these coding questions, they'll have, as we know, 60 minutes to solve two questions. Now, if you're able to solve at least one question, at least minimum criteria, one question with all test cases perfectly done, then you have really good, how do I say, you have a really good chance of going through, at least decent chance. If you're able to solve both programs, you have a better chance. Now, it all depends on how other people solve as well. So, will these be sufficient enough to crack interviews, TCS Digital interviews? First question, if you're able to get programs in which you're going to be able to apply the logic similarly. So, most of the times what happens is TCS will ask a question which has never been asked before, because they don't want you to Google it. They don't want your Googling skills. They want your logical skills. So they will always ask you questions which have never been asked before. And there aren't a lot of questions that have been never asked before. So whatever questions are there already, they will modify the current questions slightly so that such a question cannot be answered by the current program. You have to use a different logic. So the more programs we go through in our session, the more different kinds of logic we're going to see. With this, if any question is given, you should be at a point of time, you should be at a position where you can figure out, okay, this is how the question is, this is the kind of questions we had solved. If I figure out the logic is like this, and I check all the test cases like this, I should be able to crack it. It all depends on our logical ability. So all the programs we are doing are for two reasons. One is to build our logical ability. The other is to ensure that whatever logic we create, we can convert it into code. Both are equally important. So that's why we're going through all these questions. So I hope with that it can answer. So Yeah, I have one more question. There is a bank statement. Yes, I've received that today. We'll be doing a modification of that in the coming sessions. Not to worry, because we have already stated that we'll do Hollow Diamond program. So probably in one of the coming sessions we'll do that. Not to worry. All right. So let's take a look at this. Let's try working through this. Also, now the constraints or conditions in this question. So I hope I've been able to answer the questions that have been asked. Very glad to hear. So the constraints or conditions given in this question is one, you're going to be given an odd number as input. To ensure that there's a perfect rhombus, you're going to be given odd number as input. So when odd number is given as input like this, you need to write the string in this order. It just needs to keep continuing. It should not end. It should not end until it reaches the end of this. It just needs to keep continuing completely. So that's what we're going to do over here. We're going to use this particular concept. But for us to solve this problem, remember there are two inputs. One is an odd number, another is a string. You have to print the string in this order. Now, before we do this, we're going to make a small change here. Instead of printing the string, first let's just print stars. First, let's just print stars in this order. Then we can try to figure out how to convert it to this particular string. We'll think of the conversion later on. First, let's solve only for stars. This will give us the basic logic. Once our basic logic is created using this particular program, we can convert it to strings in just 3-line difference. So if such a question is asked, remember it's a modification of your star based program where they have just modified it slightly. That's all. That's what we're gonna do. So I have one question about that bank problem. I will discuss with you regarding this over time. Not to worry. You don't have to worry about that. All right. So I have one question. Is this code gonna be done in Python or other languages? So this is where we in Quantmasters are making sure that everyone gets benefited. We're not gonna just do this code in Python. We're not gonna just do this code in Java. We're gonna also do this code in C++. All three major languages will be doing it. So if you're more familiar with C++ and or let's say you want to answer only in C++, then in that case you can do this. You can use this. Or if you want to, let's say, use something else like Java also, you can do that because we'll be solving this in every programming language possible. That is these three, not every. Alright, so let's go ahead and try to solve this. So here's our basic logic. Let's say we have 7 lines or 7 is the input. If 7 is the input, our output should be 7 lines long. So for that purpose, I'm just gonna do one thing. We're gonna try this out. Think of this, guys. I'll just take an example of 7 lines. In that case, if 7 lines are there, first line 7 times I need to print. So I'll just write star here. 1, 2, 3, 4, 5, 6, and 7. In the next line, it's going to be 1, 2, 3. The middle one is skipped. Then 1, 2, and 3. In the next line, it's going to be 1, 2. The third one is skipped here. And then 1, 2. The third one is skipped here as well. In the fourth line, it's just going to be 1 and 1. Let's try the fifth line. The same thing. 1, 2. And then 2, 1. And let's sixth line. I'll just try to do this as quickly as possible. So that we can try to solve this completely. Perfect. Now, all of them may not look perfectly like stars, so please bear with that because we're just writing something random out here so that we can easily try to solve this. Now, to solve this, we need to first remember there are different lines. Please note, first thing we're doing is solving this as stars, and then we're going to convert it to our interview program with strings. We're not going to start with strings directly. So this is our easy method to do this so that we can understand this program as well as that program. And it's not going to be difficult to work through directly. Now, we should also know that there are grids. It's all about rows and columns, right? There are grids everywhere. So in any pattern program, the basic thing we need to know is that it's all about grids. Without grids, we cannot solve them. This is the first basic thing we need to know. I have one question. I have a couple of questions that let me try go through answers. Yes, in Java we will be doing it. I have one more query. Will both questions be asked in coding round involve the use of data structures? Maybe or maybe not. It purely is a randomized question that you may get. So you may get two very easy questions. You may get two moderate questions. It depends on the random number generator, or in other words, the RNG that happens. So at Kalesh's question, will you can get to know through the thumbnail of our video. Not to worry, you will be getting to know that soon enough, and I'll also communicate. Not to worry. All right, we will focus on that over time. Do not worry. Right. So let's go ahead over here very quickly. Now, in this scenario, to solve this, remember the first thing is input n is 7. So we need to print 7 lines. So I'm going to say this is first line, second line, third line, fourth, fifth, sixth, and seventh. Now here's the thing we need to know. I cannot do this in a single pattern program. Single pattern. Now, if you guys remember, we used to do something like pyramid program and inverted pyramid program. These were two separate programs. It's not a single program. So what we have here is, we have a pyramid and inverted pyramid, both one below another. So can I say I need to do two patterns here? First pattern is a pyramid, second pattern is a inverted pyramid. And the pyramid pattern will be above, inverted pyramid pattern will be below. If that is the case, I will get this exact thing. Because if you guys observe this, think of it. This is our pyramid pattern, where except for pyramid, all that is outside of pyramid, we should print stars. Then this is our inverted pyramid pattern below that, where except of pyramid, outside whatever we have, we should print stars. So can I say, in other words, this will be something like two patterns? Can I split it as two separate patterns? What do you guys think? I'll split it as this is my first pattern and this is my second pattern. Can we do this? Yes. So that's exact logic. We can do this. We're going to use it in concept of two separate pyramid programs. So let's try with the first pyramid. Let's forget the second pyramid exists. Let's try the first pyramid. Now it's completely up to us as programmers to either choose. I'll repeat. It's completely up to us as programmers to either choose first pyramid as 3 lines and second pyramid as 4 lines, or first pyramid as 4 lines and second pyramid as 3 lines. It's completely our choice. I have one question. Can we do this with two right angle triangle and reverse the right angle triangle? See, you cannot exactly reverse, because remember, if you consider, like, let's say half of it, whether you divide it in vertically or horizontally, if you divide to half of it, one of them will get an extra column. If you divide it horizontally into half, one of them will get an extra row. So you can't say both patterns are going to be same, because number of lines are odd. You cannot say both patterns are same and I'm going to reverse them. So our logic needs to be something different. I hope that's clear. Now, we're going to divide this into two patterns. The first pattern is going to be 1 to 4. The second pattern is line number 5 to 7. Now, one thing I'm just going to point out here is, since this is a live YouTube session for you guys, any question you may have regarding this program, that is whatever I am going through, whatever I am explaining, if you guys have confusions within this, you can just put it in live chat, ask me. We will ensure to answer your questions so that you can understand it even better. Whether it is on coding side, whether it is on logical side, whatever it is. With this program, any doubt that you may have, feel free to ask. Now let's start with this. I'm going to take this scenario in such a way that my first pyramid will be 4 lines, second pyramid will be 3 lines. So how am I going to figure that out? I have n as 7. When I take n by 2, I'll get 3.5. If I store it in an integer, I'll call this as P1, I'll call this as P2. If I store like size of pattern 1, size of pattern 2, we'll call this as P1 and P2. If I store P1 as n by 2, assume this is an integer. N by 2 will be 3.5. It will store only integer part of it, 3. And the next pattern size, I can put it as P2 equals n minus P1. That is whatever is left remaining. That's what we can do. So what I'm going to do here in our case is that I will take P2 equals n by 2. That is size of second pattern is 7 by 2, which comes up to be 3.5. And when we store it in an integer, it only gives me 3. Similarly, size of pattern 1, we'll call it as P1 is equal to n minus P2. This is what we can do. I have one of you stating, yes, you can also do n by 2 plus 1 and store P1 first. And then make P2 is equal to n by 2, or in other words, P2 is equal to something like n minus P1. We can do any of these. If you want to make it even more efficient, think of this. Division by 2 takes a lot of effort, right? Division takes a lot of effort. How can I make sure that this division doesn't take too much effort? There's a very simple logic to do this. A right shift n is same as a divided by 2 power n. You can use this logic. This is something a lot of us as coders would not know. A right shift n is same as a divided by 2 power n. If you take n right shift 1 instead of n by 2, if you take n right shift 1, you can take this as n divided by 2 power 1. That gives you n by 2 itself. If you really don't want to divide and you want to perform division in an easier way, in a quicker way, in a faster way, you can do this. So that's just a little thing we just need to know. So let's continue ahead from here. Let's say we just got P1 and P2 values. Now, let's say P1 here, yes, absolutely right, as Varun Prashant stated. So let's say P1 here has size 4, P2 here has size 3. I hope till here it's clear. You guys can just put it in live chat whether it's clear what we have done here, why we have divided into two pyramids, two separate patterns, how we are solving through this. Any questions you have within this also you can feel free to ask. I will ensure to answer. But if it's clear for you guys, please do just put in one text, it's clear or just clear or anything like that, so that I can definitely understand that it's clear for you guys. So that's something always positive to hear, because if you guys find it difficult, you guys have to let me know. If you guys find it clear as well, you guys have to let me know. So let's go ahead and try solving this. Here's the thing, guys. Now let's go for the first pattern. Now here the logic is very easy and simple. Once you go through this logic, any pattern program that is given, I'll repeat, any pattern program that is given, you will be definitely able to solve without a doubt. Now let's start this here. In this case, what do we have in first line? What do we have in every line? If you look at the first pattern of 4 lines, what do we have in every single line? First we have stars. After stars we have spaces. After spaces we have stars again. So stars, spaces, and then stars. So I need to print all of these 3. Now before we do that, let's go with the basic of the program. So I'm just going to take these away. All of this, we don't need any of this. So remember, input will be a number n. Based on the number n, we just need to calculate this. So I'm going to create 2 more variables, as we have just pointed out. That is int p1 and p2. P1 will be size of upper pattern, upper pyramid pattern, and p2 is size of lower pyramid pattern. That's it. This is what we have here. Now once we calculate n, we can calculate size, that is p1 and p2, very quickly. That is p1 equals, I can write n by 2 plus 1, because you are dividing by 2, that will give you 3, and then you are adding 1, which will give you 4. Instead of doing this, as I pointed out, okay, first let me do this. P2 equals n minus p1. Now all that I'm going to do here, just to show you guys, is print, or since it is C++, I'll just use cout. P1 is, let me just print them so that you guys can have a good idea. Now, if we run this, let's compile, sorry guys, let's compile this. And run this. We're gonna get something like, if I give 7, I'll get P1 is 4, P2 is 3. Now, as I pointed out earlier, instead of dividing by 2, you can do right shift by 1. If you do right shift by 1 and run this, if I give 7, I'm getting something wrong here. It's not supposed to be this. It's something very wrong here. What's happening here? When you do this, remember, plus has higher importance than right shift. Since plus has higher importance than right shift, it's going to take 1 plus 1 first. It's going to make it 2. And it's going to perform n right shift 2. And when you do n right shift 2 over here, remember, n right shift a is same as n divided by 2 power a. When you do n right shift 1 plus 1, plus has higher precedence. It's going to do like this. It's going to be n right shift 2. That is same as 7 by 2 power 2. What is 7 by 2 power 2? 7 by 4. 4 times 1 is 4. And you get some remainder. So the quotient is 1. So you get basically 1 over here. So to avoid that, we can just write bracket n right shift 1 and then add 1. That's it. So why am I doing right shift? Because it's an easier thing than division. Division takes more time, right shift takes less time. It may not be a very small difference, but that small difference may just be enough to put you ahead of others in terms of time spent to answer certain questions. That's what you need to know and be familiar with. Now, since we are clear with this, let's quickly go ahead and try the next thing. Very quickly over here. Now, since this is clear, let me just write this down in short. First, let us do the first pyramid. Let's say create upper pyramid. Then let's create lower pyramid. So let's first create the upper pyramid. Now, if you guys observe this, look at only the upper pyramid, first 4 lines. Let's forget the rest. We really don't need those values for now. In this upper pyramid, if you guys observe, what we have is, first we have stars, then we have spaces, then we have again stars. So let's consider first thing. How many lines am I printing? I'm printing P1 lines, P1 number of lines. So we have stars. If you guys observe here, there are 4 stars, then there are 3 stars, then there are 2 stars, then there is 1 star. This is the star logic. Then spaces, no spaces, then 1, then 3, then 5. This is the logic. Then for descending, you have 3 stars because this is already counted for the left one. So 3 stars, then again 3 stars, then 2 stars, then 1 star. This is the logic we have here. So this is what we need to do. After all of this, we need to go to next line. So we need to print /n at the end of all of these. So we need to print something in each of these 4 lines. After printing whatever it is, we need to go to next line. So how many lines am I printing? P1 lines. So in that case, can I write a logic like this? I'll also create 2 variables, I and j. Now here's my question. Can I write a logic like this? For I equals 1, I less than equal to P1, I plus plus, and in this for loop, I'm just printing /n. Can I say this will print P1 number of empty lines? So instead of P1, you can also consider this as N1 because N we generally associate with numbers. So I'm just going to make that change so that it's much more easier for you guys and you don't get confused whatsoever. So N1 is the number of lines for first pattern, n2 is the number of lines for second pattern. Now, since I need to print n1 number of lines, can I use a loop that repeats exactly n1 times and print /n? Will this print n1 number of empty lines? What do you guys think? Will this print n1 number of empty lines? Yes. Now, let me ask you guys one more question to top it off. Here, in this case, if you observe this very, very carefully, when I is 1, I'm supposed to print first line and then print /n. Look at this loop. Let's say n1 is 4. When I is 1, it's going to print whatever is first line and then print /n. Then I becomes 2. When I is 2, we're supposed to print whatever it is in second line and then print /n. When I increases to 3, we're going to print third line and print /n. Similarly, when I becomes 4, we're going to print fourth line and use /n. And when I becomes 5, we're going to stop right there because 5 is not less than equal to 4. 5 is not less than equal to n1. That's when we exit. So can I say on the other hand, I equals 1 means I'm printing line 1, I equals 2 means I'm printing line 2, I equals 3 means I'm printing line 3, and I equals 4 means I'm printing line 4. Can I say on the other hand, I represents line number? What do you guys think? Can I state this? Think through. Of course, I will represent line number because we are going from 1 till n1. It's pretty simple and clear. I will represent line number. So what I'm going to state here is, in this case, yes, in other words, row as well we can state it as. So row number or line number. You can call it as row number or line number. Anything is fine. So here, I represents our line number. I'll just call it as line, or you can call it as first row, second row, third row, fourth row. Both have the same meaning, but absolutely correct. So if I represents row number or line number here, then for each I value, I need to print different number of stars. That is what I need to do here. So for each row, I need to first print some stars. After printing some stars, then I need to print some spaces. After spaces, then again I need to print some stars. After the last stars, then I need to go to next line. This is the logic. So let's go for the first part, print some stars. Now, I'll give you guys a very easy logic. If you guys work through this logic, you can solve any pattern program. Generally, any pattern program can be easily solved through this logic. So let's give this a check. So take a look at this, guys. This is my row number or line number. We'll indicate it with I. And this is number of stars to print. In first line, how many stars do I print? 4 stars. 4 stars is what I'm supposed to print. Second line, 3 stars. Third line, 2 stars. Fourth line, 1 star. That is what I need to do. So let's go ahead and start here. Line number 1, 2, 3 and 4. Number of stars are 4, 3, 2 and 1. Now can I go to my code and can I type if I is equal to 1, print 4 stars or something like this. Then if I is equal to 2, let's say print 3 stars. Can I do this? Will this work? What if number of lines are changed? If number of lines are changed, number of stars in first line also changes. So we cannot use this logic everywhere. We cannot use this particular logic. This will not solve in every scenario. So we need to change the logic. We need to somehow find a different logic over here for us to work through. So let's try to figure out what other kind of logic, what difference can we possibly make over here. Now, here's the first thing. Here's the first simple thing that we need to know. In this case, I cannot use a constant like this. Number of stars cannot be changing for every line. We need to create a formula. We need to somehow create a formula so that for each line, depending on whichever line number we have, it should automatically create how many stars are there. So we will generally go for AP. This is also in AP. Yes, you can use AP formula directly here, or you can use one more method. Both can be used here. As one of you pointed out, you can definitely use AP, considering first line you have 4 spaces, second line 3, third line 2, fourth line 1. You can create AP. You can use AP to do that. We're gonna use AP for spaces because it has a difference greater than 1. Whenever difference has 1, I'll give you guys an easier method. Simple. Is it increasing or decreasing? Number of stars. Of course, it is decreasing. Since it is decreasing, convert it to number of rows. Always remember, if it is decreasing, convert it to number of rows. On the other hand, if it is increasing, convert it to row number. This is the simple logic. If it's increasing, convert it to row number. If it's decreasing, convert it to number of rows. That's it. That's the whole logic. So let's take a look at this. It is decreasing, right? So I'm going to convert it to number of rows. What is the number of rows? 4. So this will be number of rows itself. This 3 will be number of rows minus 1. This 2 will be number of rows minus 2. Similarly, this 1 will be number of rows minus 3. Now, since there's nothing here, I can also write it as minus 0. Now, if you can see, there's something increasing. Since there's something increasing and it is changing. Now, see guys, this is a constant. N1 is constant everywhere. But there's one changing value. There's one variable. I need to change this to a constant. To change it to a constant, what should I substitute it with? It is increasing now. So what do you think I should substitute it with? Any guesses, guys? Absolutely right. We're going to substitute it or convert it to I because it's increasing. So if you guys observe this, what is 0? 0 is in case of row number 1, it is I minus 1. What is 1 for 2? Again, it is I minus 1. What is 2 for 3? Again, it is I minus 1. Again, what is 3 for row number 4? When I is 4, 3 will be again I minus 1. So this is our formula. Is it constant for all lines? Yes. Since it is constant for all lines, we can easily say that we got our formula, that is n1 minus of I minus 1. That's it. That's the whole logic. So what we're going to do here is just say that number of stars we need to print is n1 minus of I minus 1. If you multiply this negative value over here, that will become n1 minus I plus 1. That means there are n1 minus I plus 1 stars in every line, in every row number I. Let's see if it is correct or not. Let's take row 3. If I take row 3, what is the total number of lines? 4. What is the I value? 3 plus 1. 4 minus 3 is 1. 1 plus 1 is 2. So row 3, there should be 2 stars. Similarly, let's try for row 1. In row 1, if you give it a try, n1 is 4 again. I will be 1 because row number 1 plus 1. 4 minus 1 plus 1, 4 itself. This is how we get to know how many stars are there. We have n1 minus, sorry guys, Let's multiply this. I plus 1 stars. That means I need to use a loop to print star these many times. So let us do that. So I'm going to use for I equals 1, I less than equal to n1 minus I plus 1, and we're going to increase I by 1 at a time, and all that we're going to print here is just a star so many times. That's it. Now remember, we're still in stars, we still haven't converted it to our string program, which we need to do. Let's try compiling this. So when we run this, we get, let's say I give 7. Now when I give 7, is this correct? Is this right? It's going on an infinite loop. Is this really correct? Something went terribly wrong in our program, right? This is not supposed to be correct. If you guys observe here, I have a loop I equals 1 here, right? So look at the initial value. Initial value I is 1. Is I less than equal to 4? Yes. So it goes in here. Here we are changing I to something else. I equals 1. I less than equal to n minus 1, n minus I plus 1 and I plus plus. So this repeats, and it repeats for I to become 3. Some value will become in this case. Once it goes back here, it increases I and goes back and repeats same thing. I value itself is being changed again and again. If you're using I for a for loop, you should not change I anywhere within that for loop. If you're using I here, it should never be changed within that loop anywhere else. Because we need to increase from 1 to 2, not something else. So to avoid that, we need to use a separate variable here for the inner for loop. We need to use something like j. That's what we're going to do. So we're going to use here, since I won't work, we're going to have to use j. Because remember, these sort of basic things we should never forget. Because we are within that I loop, we should not change it because it should increase accordingly. So if I give 7, now we are getting the right output. This is our initial number of stars we got printed right. So this is done. Now, with all of this done, 1/4 of this entire part is done. There's still so much other part remaining. Let's go on to the next part. Now, I have to figure out number of spaces. Now, if you guys observe number of spaces, how many do we have? 1, 3, and 5. Let's take a look at this. Spaces. Let's go for row number again. The same as we created earlier. So instead of stars, I'll call this as spaces. If you guys observe this time, spaces in each line will differ again. In line 1, there is 0 space. In line 2, there is 1 space. In line 3, there are 3 space. In line 4, there is 5 spaces. Now, if you observe this, since the number of spaces differ so much, in some cases it is by 1, in some cases it is by 2, in some cases it is less than I, in some cases it is equal to I, in some cases it is more than I cannot use this simple logic. I need to use some other logic. What I'm going to do here is, guys, since in line 1 we are printing 0 spaces, meaning we are not printing spaces at all, can I replace it with -1? Since we really are not printing any spaces here, can we replace it with -1 on the other hand? Because whether we print 0 space or -1 space, -2 space, -10 or -20 number of spaces, should it really make a difference? No, right? So it should only make a difference when we print a positive number of spaces. If I give 0 or any negative value, it really should not make a difference because we don't know how to print negative number of spaces. It should just exit from there. So I can change that 0 to -1. When I do this, does this look like an AP now? Does this look like an arithmetic progression? Yes. What I need to do here is find the value in ith row or find ith element of this. To find ith element, I need to use ti equals a plus I minus 1 times d. This is the formula of AP we have. We're going to use the same thing because remember, common difference is same with every line. And you can consider this as the first term, this is the second term, third term, fourth term are these. I need to find ith term so that I can get to know how many spaces to print in line number I. So I hope that now it is very, very clear. Again, if it's confusing, feel free to let me know, guys. Ask the question. But I hope now it is very clear how this works. For line number I need to print basically some sort of like I spaces. These many spaces. Now, what's the starting element of this arithmetic progression? It is minus 1. So minus 1 I can say is equal to my initial element A. And what is the common difference? Can you guys figure out and tell me through this program? What's the common difference we have over here within this arithmetic progression? Very simple question. Absolutely right. We got 2. I have one question. Instead of AP, can we use the same logic that we use to print stars? You can, but since the numbers are changing in a very different way, you don't know how exactly to convert them. When there is single change in numbers, it is easy to convert. Now when it is changing like this, it becomes slightly more difficult to convert because in one case it is I minus 1, in another case it is I plus 1, in another case it is I plus 2. So in that relation, it is going to be difficult for us to calculate. So that's why whenever there is a difference of 1, we do that simple logic. Whenever there's difference of more than 1, we end up going for AP. Now consider in this all the difference has a common difference too. If there is no common difference, we cannot use AP also, we need to use some different technique. So here we have a common difference too, as rightly pointed out by many of you. So we're going to use that same value over here. I don't think this we need anymore. Let's go ahead here. Yeah. So Ti, the ith term will be calculated as, what's our initial A value? Minus 1 plus I minus 1 times the common difference is 2. So let's multiply this. It is minus 1 plus multiply 2 into I and then multiply 2 into minus 1. That is supposed to be minus 2. So this is what we get. So if you calculate this, you get something like 2I minus 3. Minus 1 minus 2 gives you minus 3. So there's supposed to be 2I minus 3 spaces in each line. Let's see if this is correct. Let's take row 1. Let's take row 4 for example. In row 1, 2 times 1 minus 3. That is 2 minus 3. That gives us minus 1. Minus 1 means we can't print spaces. Only if the value is greater than 0, we're going to print space. Now in row 4, 2 times 4 is 8. 8 minus 3 will give you 5. So does row 4 have 5 spaces? 1, 2, 3, 4 and 5. So it's correct. So our logic for spaces is absolutely right. So let's take this scenario. We're going to write for how many times am I supposed to repeat spaces? 2i minus 3 times. So I need to print spaces that many times. For j equals 1, I can use j again because we have just finished using j here. So there's no problem in using the same variable once more because that loop is already finished. For j equals 1, j less than equal to 2 times I minus 3. This is how many times we have to repeat. And we're going to use j plus plus. And we're just going to print just a space. Now the problem here is we can't see the space in output. Even when we compile and try, hold on guys, something is wrong. Sorry, it is minus. Alright. Even if we compile and run, we can't see the output here. If I give something like 7, I cannot see spaces. So to see spaces, I'll just replace it with hyphen. Let's see if it works. Just to observe that. Here I get to see if I give 7, I get these values as expected. So first line no, second line 1, third line 3, fourth line 5 spaces. So this now works perfectly. This is perfect. Now let's go ahead and do the last part where we need to print some stars. Now, in the last part, if you guys observe, to print stars, how many stars am I supposed to print in first line? Can you guys think and tell me? I'll only write the other lines. I want you guys to figure out and tell me how many lines am I supposed to print in first line. Second line I have 3 stars, third line I have 2 stars, fourth line I have 1 star. What about first line? First line is 3. It is not 4, it is 3. Because 4 we have already printed here. 4 stars we have already considered here. In this case, I'm only supposed to take 3 stars. So that's what we're going to do. We are only supposed to take 3 stars over here. So let's give this a try and see how exactly it works. Now, isn't this similar to first logic? In first logic, 4, 3, 2, 1. Here also, 4, 3, 2, 1. Except in first line, I need to print 3 stars only. That's it. So, what I'll do here is, since it is very similar to first case, I'll copy and paste it entirely here. But first line, I need to change logic. Everything is same. Everything else is same. Only first line, I need to change logic. So here I'll give a special condition in this for loop. I need to give a special condition only for the line number 1. That is, if j is equal to 1, that means if we are in line number 1, then we need to print a separate number of stars. Please remember, we need to print separate number of stars for first line and separate number of stars for other lines. So when j equals 1, we need to print separate number of stars. How many stars are we going to print for j equals 1? 3. Now I cannot write just 3 directly, because if I write 3, even if I'm supposed to give a larger, let's say a very larger hollow diamond, even then it's going to print 3. So absolutely right. Sorry, one of you just pointed out. Very glad that you pointed out. If I equals 1 is the scenario, right? If I equals 1, I need to make one small change. I'm going to take this entire for loop within this case. If we are in line number 1, we have to consider that we are in line number 2. We have to print number of lines. See guys, we have to print number of stars equal to what we are printing in line 2 if we are in line 1. So that is why I am writing if line number 1, line number is represented by I. If line number 1, number of spaces printed, we will change entirely to line number as 2. We're going to consider it as 2. This is how we're going to repeat. So for this, if you don't want to use j, because j you're using here, you can keep it to something like k as well. Now there's a better way to do this, which I'll explain. Without using this loop, there's a much better way to do this, which I'll explain. That is, we'll try here. Now, other way to do this is, how many spaces do you exactly need to print? You can see here, n1 is 4 lines. Since n1 is 4 lines, this is 3. So you can say it directly as n1 minus 1. Since n1 minus 2 plus 1 is basically n1 minus 1 itself. So I can give this condition and print separate case over here. This is only for the first line. For all other lines, it's going to skip this. It's going to go directly here. So let's give this a try. I'm not sure whether this works. Let's run this. Let's compile this. Again, k is not declared. Let's also do that. Now let's compile this and run this. If I give something like 9, I'm going to get this. Is this correct for first line? Now comes the confusion. Is this really correct for the first line? What is going on here? Whether we are in first line or not, we are printing either way. So if it is first line only, then print. Otherwise, else go for this scenario? Now remember, what else is happening here is, if we are in first line, we are repeating for every element. This logic is not correct. I'll show you why this logic is really not correct. If you guys observe this, we are in line number 1. J equals 1 means we are in line number 1. When we are in line number 1, we are repeating how many times? 3 times. In each of those 3 times, I will be 1 itself. Is that right? No, right? So why is it repeating so many times? Think of this, guys. This is I value. I value will remain 1. Are we changing I here? No. We are not changing I over there whatsoever. We are not changing I over here. Since we are not changing I over here, if line number is 1, for all of these times, this condition will be true. So it prints so many times. We have to avoid this condition. There's a simple logic to avoid the condition. The logic goes like this. Here you're going to have to state, if line is 1, if you're in first line, do something. Else, you do something. If you're in first line, do your logic as n1 minus 1 lines. If you're not in first line, do this particular logic where, sorry guys, we'll copy this, where you're going to do something like this. That's it. This is if you're in first line, it is n1 minus 1. If you're in other lines, apart from first line, you're going to do this. That's the entire logic. That's it. Nothing else. Now, let's see if it works. This is, remember again, please note and remember again, this is the first half of the hollow diamond, not entire hollow diamond. It's only first half of the hollow diamond. So if I give 4 over here, we're getting like this. Sorry, we're not supposed to give even numbers. If I give 9 over here, we get this. If I give, let's say, 11 over here, we get this. Similarly, if I give, in our case, whatever we did earlier, 7 over here, we get this. This is our simple logic to work through this. I hope it's simple, easy, and really not difficult for us to work through. I hope it's very, very easy for us to do. So this is our entire logic for our first half of the hollow diamond. Is this so far clear, guys? My question to all of you, is this so far clear? Is there any confusions, any questions in your mind till here? You guys can feel free to ask. Take a couple of minutes, ask. If there are any questions, queries, I will ensure to answer them. If there are none, we'll go ahead over to the next part, that is lower pyramid. So if you guys are clear with this, if this is very clear and easy to understand, I request all of you to just put in one text over live chat like, yes, got it, no issues. We'll go to the lower pyramid. If you have any questions, confusions, please shoot it through right away in the live chat. I will ensure to answer the same to you. So you guys can let me know. Do not hesitate. Do not worry. I just want to make sure that you guys are able to understand. That's it. So you can let me know. So glad that it's clear. Glad that it's very clear to everyone. So that's a very good sign. So let's go ahead and try to work through the lower pyramid problem. Upper pyramid is done. Now we're going to do the lower pyramid. Now, here's the thing. For us to do the lower pyramid, I need to repeat the same steps again. Exact same steps again. This time, instead of 4 lines, the difference is I will only have 3 lines. I'll only have 3 lines. That is 1, 2, and 3. That first line will be this, second line will be this, third line will be this. I have a couple of questions before I go ahead. One is, which programming is this? Because I've just joined now. So this is a hollow diamond problem where we are supposed to print string like this by giving a hollow diamond in between. But before we start with strings, we are first doing the same thing with stars. And then we're going to convert that stars to strings. So we can understand both programs. I have one more question. Can we store line number and increment m equals I with previous logic? Yes, you can use line number here as 5 itself and do. Not a problem. But the problem here is we are generally accustomed to solve this as line number 1 to n. We generally keep it in our mind that if I'm starting a pyramid, I'm starting at line 1. That is how we generally keep it in our mind. That is why I'm starting with line 1. If you want to make it easy, this is a simple trick I'll give you guys. Not a lot of people work with this trick, but this is a simple trick that I'll give you guys to solve it in an easy way. I have one question. Is time complexity sufficient for such a big program? See, here's the thing. If you want to solve the entire thing in one for loop, the entire logic gets crumbled. It becomes way too complicated and crumbled. So this is the best logic. So what's happening here is, of course, your entire for loop will go through something like big of n square to n cube. It will. Because for each row you're going through something else and working through. Absolutely right. If you really want to make it something different, you can change something else. Remember, what we have done here is, remember the space formula? We have not considered separate spaces here and here. If we also divided this and considered this as a separate space formula, and we considered this as a separate space formula as well, then it would have been much more difficult for us to solve. Then it would have taken much more time. If you want to make the time complexity a little lesser, I'll give you a clue. Here, Aditya's question, okay, you weren't able to understand spaces formula. See, here it is. The spaces formula is based on arithmetic progression. In first line, there are no spaces. So I'll write -1. In second line, there's 1 space. In third line, there is 3 space. In fourth line, there is 5 space. Isn't this in a form of arithmetic progression? There is line by line or value by value. You're increasing with a common difference. The common difference is 2. Using this common difference as 2 and initial value a as 1 and common difference as 2, we find the ith term here, that is, let me just quickly write it. Ti equals a plus n minus 1, a plus I minus 1 into d, where a is the initial value. What is the initial value? -1 that we had. So I'll take -1 plus I minus 1 into, what is the common difference? That is 2. If you calculate this, you get 2i minus 3. That is the number of spaces you have in line number or row number I. I hope that explains the entire logic at Aditya Sahu's question. Now going back to Dinesh's question. How can we make our time complexity a little better? Think of this. First line, anyway you have stars everywhere, right? Anyway you have stars everywhere. You can skip the first line from your pattern and you can print n stars directly. And then from second line you can go to your loop. First line you can skip directly and print n stars. Only from second line you can go to loop. Even this you can do. There are a lot of slight advantages we can do, but I'm going through the general programming method initially so that we all can understand this very, very clearly. Now, with this, let me give you guys one little clue on how you can do the lower pyramid. See guys, you can start either as line 1 or you can start as line 2, up to you. I'll start as line 1, 1, 2 and 3. In line 1, how many stars are there? 2. In line 2, how many stars are there? 3. In line 3, how many stars are there? 4. So can I say in line I have I plus 1 stars? Makes sense, right? Absolutely makes sense. For line I have I plus 1 stars. Perfect. So I'm just going to go ahead and print here for the second lower pyramid. That is, for I equals 1, I less than equal to n2, not n1 this time, I plus plus. So the first thing is print slash n. This is to go to next line. But before we go to next line, we need to do a certain set of things. Please remember, first thing is print stars, then print spaces, and finally we'll go for print stars again, then go for next line. This is our simple logic. So first thing is we need to print I plus 1 stars. So I'm just going to use for j equals 1, j less than equal to I plus 1, because we are supposed to repeat I plus 1 times. We're just going to print stars. That's it. Now let's see what happens in the output. Let's compile this, run this. I'll give something like 7. We got it absolutely perfect. Now I don't need this hyphen anymore. I can remove this hyphen because first part is done. I can remove the hyphen and make it space again. We'll do that change. Now let's compile and run. We got this perfectly done. So 2/3, nearly 3/4 of it is done. Nearly 70% of it is done. If I give 15 lines, for example, sorry guys, if I give 15 lines, for example, it's gonna give me the hollow pyramid exactly to 15 lines. But this part is pending. It's not closed yet. Now, can you guys try to figure out what will be the for loop for spaces and stars? We'll see if you guys can answer this in our next session, in our tomorrow's session. We'll see if you guys can figure this out. This is my first statement that I want you guys to try, and this is my second statement that I want you guys to try. Can you guys figure it out by the next 23 hours before our next session? This is my question to all of you. It doesn't matter if it's right or wrong. Give it a try. I want you guys to try figuring it out. So, what do you guys think? Confident enough to figure it out, or do you still think it's going to be too difficult? So few of you are stating that you are confident to figure this out. You are confident to try this out. Let's see how many of you will be able to work through this, because I want to see the response from you guys by tomorrow's sessions. But don't worry, if you find it difficult, we will help you solve it. So glad that you guys want to try it out. So we'll just share the link here with this content so that you can access it and try to solve this particular problem. You can run this program to see what happens and try to figure out this question mark part. So give it a try guys today, and we'll see how many of you will be able to solve it. And if you are all able to solve it, that's awesome. I'll be very happy to see the response. If you find it a little difficult, don't worry, we will solve it tomorrow and then convert it to this particular program. So with that, we'll end our session. We'll catch up tomorrow. It's gonna be probably the same time. Do check Quantmasters once tomorrow to confirm. It'll be same time as far as we are concerned. All right. So we'll catch up tomorrow, guys. So until then, keep practicing, keep preparing well. Have a good night, guys.